Okay, we're getting to be pretty good with radicals. Now today we're going to talk about powers and roots of negative numbers. Most of our work has been with the positive base numbers. Now we're going to also include some negatives and see what kind of changes, if any, have to be made. So students are going to be able to evaluate radicals that have both positive and negative bases. We've done that. Solve equations with radicals and apply the rules, and also interpret some graphs of inverses. So let's go step by step. Let's start with the idea of powers and roots of negative numbers. If you look at this, it's very similar to our scale of when we did positive numbers. But start thinking, what does result when you do a negative number's power? Okay? If I took -2 and took it to the 0 power, remember, -2, anything, actually, not just -2, anything to the 0 power is dividing by itself. So it would be a -2 divided by a -2, and that is definitely a 1. Then if I took -2 to the first power, that meant I would have one -2, and that definitely is a negative. Then if I take -2 to the second, well, that's a negative times a negative, which is in this case, +4. If we go to the third power, now we have that group, and some of you think of this, I got two things that go together, and then I have the extra one that doesn't. And if they're both negative signs, that's how some people are looking at this. If they're both negative signs, and I got that one that's not, then we got a problem. And we're definitely going to have a negative, and we would have a -8 in this case. So again, now if I had 4 negative signs, that's 2 groups of 2, and so therefore we are back to the +16. So start looking. There are definitely some patterns here. Do you notice, again, that anything to the 0 power is always 1? It's the only one here that's not a multiple of 2. Then you're starting to notice I have the odd-powered negative. And on my odd power negatives, notice, we don't care how big the number is, but we do care if it's an odd amount of negatives that we're multiplying, we are going to get a negative result. If it's an even amount of negatives, 2's even, 4's even, 0 is not considered even, we get a positive result. So if we have an even amount of negatives, it should be positive. If we have an odd amount of negatives, it should be a negative result. Keep those things in mind as we start to simplify powers and roots. So here we go. When multiplying, all even powers of negative numbers equal positive answers. That's what we were just talking about in our display there. So if I have a -3, doesn't matter what the number is, and I take it 4 times, that gives me 1, 2, 3, 4 negative signs. Groups of 2 gives me a positive, so we're going to get a positive answer. Any odd power of negative will always give me negative numbers. So with that result, let's move forward and see what we're going to do. Write this expression, -6 to the 4th times -6 to the 5th, as a power. Now remember, we have a rule. If your bases are alike, they are, the rule was add the exponents. So we're going to add, and when we add 4 plus -5, most of you know that leaves us with a -1. And it just says write as a power. So we want to leave it just like this. It doesn't say turn me to a fraction, turn me to a decimal, turn me to a number. We should be looking at exactly what we have. Okay. Next one. Keeping in mind our odd versus even combination. Now here's a good look. You have a -2. And it's taken to the 5th power, so start thinking, what am I going to be? That's part of the work. And also start thinking order of operations, because there is something here that has to be done. We have a 5th power and a 5th root. We have an 8th power and an 8th root. But by order of operations, one gets done before the other. So think about that carefully. Would you have put down a positive, or would you have put down a negative? Would you have put down a positive here, or would you have put down a negative? Yes, there's numbers, but the whole point is it positive or negative? Top one should have been negative. Bottom one should have been positive. And here's the reason. A negative 2 would be 5 negative numbers. 1, 2, whoops. 1, 2, 3, 4, 5. Every group of 2 gives me a positive. So when I multiplied just negative 2 to the 5th, I would have had a negative number underneath. Can I take a negative number's 5th root? Yes, because you can take an odd. So we are getting a negative on this one, and it would be a negative 2. On this one, though, when you think about your combinations, 8 is an even number. If I have an even amount of negative 2's, what's underneath here would have been positive before I started, versus up here, what's underneath would have been negative. And so when you take a 8th root of a positive number, you would always get a positive. So that's the thinking. Look at what's going on. This would be a positive number that you're taking the root of. This would have been a negative number that you're taking the root of. All right, let's try a couple then and just go one step further with our negatives. So is there a number that I can multiply 5 times by and get a negative number? And of course the answer is yes, because there's an odd amount. So now the question is there a whole number? Because that's what we like better than decimals. So what number multiplies by itself? Well, 2 is not going to be too good because we got a 3 on the end. 2 only gives us even numbers on the end. So let's start with the 3. 3 times 3 is 9, and we knew 2 more 9's, or sorry, not 2 more 9's, 2 more 3's would give us another 9, so that's 4 3's would give us 81, and 81 times 3, which would be 5 3's, gives us that 243. Now, if we were multiplying and we made them all negative, that would have given our answer a negative answer at the end. And so our final answer here would be that one number that multiplies by itself 5 times would have been a negative 3. Now do the same thing with the 5th root. You're going to say, well, what one number multiplies by itself? 2, possibly. So here we go. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Ooh, that's a little small, but keep that in mind. If we go 4, or even 3, we just did 3 a minute ago. 3 times 3 is 9, times 3 is 27, times 3 is 81. That's closer, but too small. If we go to 5, 5 times 5 is 25, times 5 is 125. That's too big, and we haven't even multiplied it 5 times. So this is telling us that I'm really not a perfect 5th root number. But if you go back to that first thing we did, the 32, I believe it was, and we did negative 2 to the 5th power. Negative 2 to the 5th power was a negative 32. Now look at that carefully. Negative 32 times what is negative 96? In other words, break it down. 32 goes into it. Use your calculator if you have to. Negative 32, you can see, goes in there 3 times. So your thinking to breaking it down should be, well, this is still the 5th root of negative 32, which is a perfect 5th root number, and a leftover of a 3. So you should be able to say the 5th root of negative 32 is 2 with a 3 under the 5th root sign, and it was a negative 2, sorry, and a 3 that's left over. So that's how I would work that one down. So break it down if it's not a perfect combination and try to find perfect 5th root numbers. So we're getting better at those. Break it down into perfect 5th roots. And that combination, you would have only been doing 2 to the 5th, 3 to the 5th, 4 to the 5th. I don't even think we did 4 to the 5th. 5 to the 5th we jumped to. All right, so you can see there's not a lot of possibilities that go into that. And you can use your calculator to help break it down. All right, so a lot of similarities. The only difference, we've got that negative involved, so double check it. Keep that in mind. Is my answer going to be positive or negative? It does make a difference on how many base numbers or roots you actually have in your work.